Hey everybody, it's Mr. Zabo. Before we start the complete review to prepare ourselves for the quiz for 9.4 and 9.6, I want to bring back one old idea and then kind of extend that into something a little bit new today. That idea is solving by taking square roots. We did this in section 9.3. So go ahead and try these first two examples. I know this week we have also reviewed this slightly. Press pause to start right away and see what you can do with numbers 1 and 2. So hopefully we got to this idea, and this is really the key idea in order to get to our extension today, but we have to get our exponent squared by itself first. In this case it's x squared equals 9, then we can take our square root of both sides, or y squared equals 36, then we can take the square root of both sides. The other thing you have to remember about this is by doing this, the square root of x squared is x, but since I'm doing this on both sides, this is a plus or minus on this. What is the square root of 9? What multiplies by itself to give me 9? That is 3 or negative 3. And there's two possible answers. We've been writing it like this. We've spent some time writing it with plus or minus, but I think the key today is going to be writing it as two separate problems. X is equal to 3 or x is equal to negative 3. I want us to get into that habit that when we were writing it with the comma or we were writing it with the plus or minus, this is really what it meant. That's going to be really important in the extension we look at in a moment. Okay? So for the same example, this one would be y equals positive 6 or y equals negative 6. If that doesn't make sense, go back and review your notes from section 9.3. For the extension that I want to look at today is all about what we call vertex form. When we're talking about vertex form of a quadratic function, we talked earlier about standard form. And standard form is ax squared plus bx plus c, and if I wanted to find the vertex of that, I'd have to do the opposite of b divided by 2a to get the x coordinate, substitute back in and get the y coordinate. However, if our function was in what we call vertex form, so remember in linear equations we had different forms as well. We had slope-intercept form, point-slope form. Each gave me different pieces of information that were valuable. Vertex form gives me really important information, specifically the vertex. The vertex of a quadratic function, when a function is in vertex form, is always going to be at the coordinates here. So this is the generic function for vertex form. In this case you have x minus 2 quantity squared minus 4. For the generic function, it's this, and your vertex is at h comma k. H is your coordinate for your x at the vertex, k is the coordinate of the y at your vertex. In this particular case, you would have your x coordinate, since it's already x minus 2, it would be at 2, since the function calls for x minus h. And the y coordinate, you have a minus 4, since that's a plus k, means the exact value of k. The exact value here is negative 4. So the vertex is at negative 4. Now, finding your vertex is the easy part if you know those rules. Solving by taking square roots can be just as easy. So in this particular case, I can identify my vertex just like we did up here. H, since it's x minus h quantity squared, everything matches up. My x coordinate is 2, and it's plus k, this is minus 4, it's negative 4. Okay. Go ahead and press pause. Try the vertex for number 4. Now, did you remember to put it in standard form first? That's something that's consistent in everything we've done. We'd have to get this equal to 0 first. Now that it's equal to 0, my function is in vertex form. X coordinate is the opposite of what I'm doing to my x value. In this case, plus 1. My x coordinate's negative 1. I had to subtract 64 to both sides, so my k value is negative 64. Alright, that said, to solve by taking square roots here, it's a different story. I don't want it equal to 0. In the previous problems, we wanted to get x squared by itself, then square root both sides. But now I don't want to get x squared by itself. I don't want to have to multiply all of this out. What I want is my entire quantity squared by itself. So in a problem like this, that would require me adding 4 to both sides. I keep this x minus 2, and now it's equal to 4. Now that I have my quantity squared equal to 4, I can take the square root of both sides. And the square root of this is x minus 2. Here's where things get tricky. When we take the square root of both sides of our equal sign, it's not just one answer. This is equal to 2 possible answers. The square root of 4 could be 2, or it could be negative 2. So x minus 2 could equal 2 or negative 2. And now I'm not done. Now I've got one additional step left in solving this. I have to add 2 to both sides here, and I have a root, a solution, or a 0 at x equals 4. That would be at 4, 0. And I have another root, a solution, or a 0 at x equals 0, which would be at the origin. Those would be my roots, my solutions, or my zeros. So that means in number 4, while I needed to do this to get my vertex, to get my roots, I want to go straight from the first problem to get my roots, because it's already got its quantity squared isolated. I'm going to square root both sides and get x plus 1 equals 2 possible solutions. X plus 1 could equal a positive 8. It could equal a negative 8. Therefore, x could equal 7 or negative 9. And those are my roots, my solutions, my zeros, my x-intercepts. Go ahead and take a minute and try numbers 5 and 6. Press pause and then try. So since they are both in vertex form already, that made finding the vertex easier on these two, but it's going to be a little work to find the roots. So for number 5, we have to add 9 to both sides, then square root, so x plus 4 is 3 or negative 3, which makes x negative 1 or negative 7. But number 6 is a little trickier. When I subtract 1 from both sides, I get x minus 8 quantity squared equals negative 1. But if I square root both sides here, I end up with a pretty tricky situation. That can't happen. We can't do this, so there are no roots or no real solutions. If we write no real solutions, no roots, no solutions, all of that is saying the same thing. When we take the square root of a negative number, it represents that there are no solutions to that quadratic function. Alright, so for the rest of the class period, I want you guys to work on the rest of this packet. It's going to be a combination of solve by factoring and solve using the quadratic formula. I will shortly put out a second video with the answers.